Hello, today we're going to see how to convert periodic decimals to fractions. Remember that when you have decimals, you have decimals, normal decimal numbers where you have fixed amount of digits, okay? Then you have uh, periodic decimals where you have an infinite number of decimals, but it's something that is repeated. Okay, this too can be converted into fractions, both of them. Okay, and we have videos about both. The first one on an older video, and this is the one that we're going to see today. And then you have the irrational numbers, which are numbers that have infinite number of different non-repeated digits, and this cannot be, irrational numbers cannot be converted into fractions. Okay, so today we're going to see how to convert a periodic decimal into fractions. Why do we want to do this? Well, basically because A, it's easier to write a fraction than something that is repeated infinitely, and B, because it's easy to work with fractions, and it's not so easy to work with decimals. Okay, so I've given you here some examples. As you see, the first one, the 8 is the one that is repeated. We can put a dot on top of that, or we can put a slash or an arc. Normally, the arc and the slash are reserved when there's various digits. Here in the second one, there's two digits that are repeating themselves. We put an arc, we can put a dash on top. Now, in the third one, we have three digits, and the fourth one is a special case where something is repeated, but it's not not everything in the decimal places is repeated, just apart. Okay, and you'll see that the method that you have to be a bit more careful with the last exercise. Okay, so let's give you the method in the first example. So we're going to call x to whatever number they give us. Okay. Then the next step we're going to do in the method is that we're going to multiply this x by 10, so as many times as we can get one of the series that is repeated, in this case the 8, on to the left of the decimal of the decimal symbol. Okay, so for example, this is 0.88888. So what we need is to multiply by 10, so we get one sequence of the series to the left of the decimal symbol. So obviously we need to multiply by 10, and then we have 8.8, and that's a periodic. And then we have for the second step of the method, the second part of the method, we're going to multiply x as many times as we need by 10 again, so that we get the sequence that is repeated just after the decimal symbol. But in this case, we don't have to do it, nor in the first three cases, because the sequence is already to the left of the decimal symbol. So we can imagine that we're multiplying by 1, or that when we don't have to do anything when the sequence is just beside the decimal symbol. Okay, so we are going to subtract the x. Why do I give you this second step? You'll see, because we need it for the last example, and I'll repeat it on each one of them. Okay, so now we're going to subtract that. 10x minus x is 9x. And then we're going to subtract this. This is a decimal with an infinite number of digits, and this is another decimal with the same infinite number of digits. So even if they're infinite, they're both the same, so they cancel each other. And then it's 8 minus 0 is 8. So if we make x the subject of this, we have 8 divided by 9, which, if you check in the calculator, they all have a method where you convert fractions into decimals. You'll see that that will give you 0.88888. Okay, so let's do the second example. We call this x. We're going to multiply by 10 as many times as we need, so that there's one sequence to the left of the decimal symbol. So that's 1, 2, 100. We have to multiply by 100. So 100x is 132. And then we have the rest repeated indefinitely. Okay. Then we have to multiply by 10 as many times as we need, so that we get the sequence just to the right of the decimal symbol, but we have it like that, so we're going to subtract again the x. We don't have to multiply by anything. So now if we do this again, the infinite part is the same, so That's 132 minus 1 is 131. 100x minus x is 99x. So now x is 131 divided by 99. Always check if you can simplify this fraction, but 99 can be divided into by 3 and by 11, and 131 can't. So that's as simplified as you can get. The next example is this one. So we call that x. Again, we multiply so that we get the first sequence to the left. So that's 1000x is 7545, 545. And then we multiply so that we get the sequence just to the right, but we already have it like that, so we don't have to do anything there. Okay, and we subtract that, we get 999x, and then we get 7. Again, the part that it's repeated is the same, so we can subtract that, and we get 7545 minus 7 is 7538, and then so x equals 7538 divided by 999, which, if you can check in the calculator, cannot be simplified, and if it will give you the result that we need. Check in the calculator if you want. Okay, so now we're going to do the third part, which is the interesting one, 163, where we only repeat the 63. Okay, we're going to call that x as always, but now we're going to multiply again so that we can get the sequence just to the left of the decimal symbol. So it's 1000x equals 916363. Okay. And now this is the part that changes. That's why I repeat it every time. We have to get the sequence just to the right of the decimal place. So we have to multiply by 10. So we get 91.63, and that's just to the left, to the right, sorry, of the decimal place. Okay. So again, the first part we multiplied, so we get one series of the sequence to the left of the decimal symbol, and the next part we multiplied by 10 so that we get the sequence just to the right of the decimal place. So that's why we multiply by 10. If we subtract this, we get 990. X equals, again, the part that is repeating will subtract itself, and we get 9163 minus 91. So if we do that, we get x equals 9163 minus 61. 9163 minus 91. 91 is 9072, and then the other part was the multiplying, so we send it dividing. As you see, both of them are even numbers, so we can divide them and simplify it. And so if we simplify that, we will get, in the end, 504 divided by 55. And that's the fraction that we need. Okay, you can check in the calculator, and I recommend you do. So again, let's go over the method. We have a periodic decimal. We want to convert it into a fraction. We call it x. We firstly multiply by 10 as many times as we can get the first sequence of the series just to the left of the decimal place, and then we multiply it by 10 if needed, so that we can get that sequence just to the right of the decimal place. We subtract both equations, and we get an expression that when we leave x as the subject, we get the fraction that we need. And it's as easy as that. Okay.